Good afternoon, everyone. Okay, so let's start off with R. In last session, what we saw is application of analytics. We saw certain examples of how analytics is used, how Airbus is coming up with new aircraft, which will have 10,000 sensors on each side of the wings, banks, how banks are using analytics, and so forth. And we started off with basic commands in R, wherein we executed a couple of commands like help, get WD, set WD, and we saw the interface of a basic interface of R. Okay, and we did the installation of packages and other things. So let's start off from where we left last time. So we had seen all these things and we had skipped couple certain slides, but we'll continue with understanding of R data structures. Okay. First and foremost, we saw variable in R. There are certain rules whenever we declare variables. There are certain rules each tool imposes on how you can name variables in that programming software. Likewise, we saw that R also has got certain rules. Variables can be alphanumeric. It can have underscore and dot. These two special characters it can have as part of the R variable names. Also, we saw that a variable name cannot start with a number. Variable name has to always start with the alphabet, or it can start with dot, but it cannot start with a number or underscore. Thirdly, we knew that special characters that like plus, minus, division, multiplication, dollar, pound, hash, braces, bracket, question mark, these kind of special characters and mathematical operators cannot be part of a variable naming convention. Yeah. Finally, it was suggested that inbuilt variable names, we should try avoiding those inbuilt variable names. If we create a variable having same name as an inbuilt variable name, it may so happen that the inbuilt variable name, we may not be able to access it directly. And one of the example we took was pi. We created a variable name pi in small case. We assigned the value and then we tried to access the inbuilt variable which is pi of the base package, and we could not access the value directly. In that case, we had to use the namespace. That is, we had to say base colon colon and then we had to specify the pi. So this is what we had done. Likewise, we completed this slide where we started off with the basic variables, where we said A is equal to 10, B equal to 15, C equal to A plus B. These were certain commands that we executed. I'm using RStudio. So in case you people have installed RStudio, you may use RStudio, or probably you can you continue using the base interface. So these are the commands that we executed, and when we executed these commands, variable A, variable B and variable C got created. Where are these variables created? In memory, in RAM. So these variables gets created in RAM. Okay. We also saw that in R you can use equal to assign a value to a variable, or we can use angular bracket hyphen to assign a value to a variable. So either of the conventions is okay. I am going to run these commands also. These were some basic commands that we executed. Pi is basically an inbuilt variable. I have not declared it, and when I just type pi, automatically the variable value comes up. We then overwrote by creating a user defined variable, and then we access the variable pi. In that case, this variable PI is now created in a global environment, which is your global environment, and that's why it is now giving a value 3.14 instead of giving 3.1593. To access the original pi, which is the inbuilt variable, we had to use the namespace command, namespace way of writing command. It is using double colon and then saying PI. So this is the command, and now I am able to access the same variable again. So these were certain commands that we executed in our last session. Yeah. Let's move forward from there. So when we create a single value variable, we call it scalar. When we create a single value variable, here a is equal to 10. How many values we have associated with a? 1, which is 10. When I say b is equal to 20, how many values we have associated with b? 1, which is 20. If I associate a sequence of values, that is called vector. That is called vector. Now if I have to associate a sequence of value, I cannot write something like this. X, I want to create a variable x and I want to associate 5, 3, 2. I cannot write this command like this. If I write it, I'll get an unexpected error. Okay. Why you get this unexpected error? Any idea? When you write this command 5, 3, 2, variable not assigned by? Variable values cannot be assigned by comma. See, the reason is when you are saying 5, 3, 2, comma is not a numeric value. It is part of string character. If it has to be a character, then in programming language, character values are always enclosed between double quote or single quote. I repeat, character values are always enclosed between double quote or single quote. Now it does not know when it is 5, 3, 2, it does not know whether comma, when you have put comma, where you were trying to put a string value or whether you were trying to put a sequence of numeric values. See, compiler, there has to be some grammar, right? In English language, we have grammar. In Hindi language, we have grammar. In Marathi language, we have grammar. In any language, there is always a grammar. So similarly, programming languages has its own grammar. And here when we say 5, 3, 2, it is not able to understand what you wish to do. So it is not able to compile that or interpret that statement. Okay. Because it is not able to interpret, it is given you error unexpected comma. It is saying that the comma was unexpectedly found. Right. Now if you want to associate a sequence of values which are numeric, how do you go about doing it? So in that case, you have to write the command like this. There is a function C, small case. Now let's understand what is a function. In Excel, you have used functions. All of you. Weber, in Excel you have used functions. Which function you have used in Excel? Sum, trim, yeah, right? Now when you use a function, say sum in Excel, and you select a range of cells, what does that function sum do? It adds up all the values which are in the selected range and returns the value which is the addition. So there are two steps here. First step is performing the process of adding. After performing the process of adding, the second step is returning that value. A function in any programming language is always supposed to do certain operations which are defined inside that function. At end of performing the operation, it is supposed to return a value. That is a function. A function in any programming language. I'm not talking just of R. It's a generic concept. A function in any programming concept is supposed to execute the operational logic which is written inside it. After executing the logic, it is supposed to return a value, one object. When I say one value, I mean a object. That object may have hundreds of values, that is a different thing, but it has to return a object, an object. If it does sequence of processes, steps, and then does not return a value back, that is typically called procedure. That is typically we use the word procedure. So here C is a function. Small case c is a function to which I pass the value 5, 3, 2. And that function will return an object of type vector, which will have three values in it. Okay? So when I run this command, you immediately get the output on the screen. I have not selected x equal to. I just selected C532 and I executed it. And the moment I executed it, it gave me the values 532 on the screen itself. Okay? But when I run this same command like this, I do not get anything on my console screen. It just executes and there is nothing printed on my console. Why? It is assigning a value for x. So what is happening is, yes, what you are saying is right. It is assigning a value to x. What is happening is when you executed this like this, the function executed, it has to return a value. The moment it returned a value, was there anyone to catch that value? No. So because there was no one to catch that value, that object, so the only thing that was available for the system to catch and was to display it on the monitor screen. As such, 532 got displayed on the screen. Right? But the moment I said x is equal to C532 and I execute this command, C function 532 parameters, it executed, it returned an object. Now variable named as x is standing there to catch it. So it has caught that object and that's why it is not displayed on the screen. Are you getting? See, writing to screen is also a function kind of a thing, a activity. So here x caught it and it is not displaying anything. Making sense? No.
So just a question. You see the function. Okay, so function has three parameters or three values. So function, from what I have a bit of knowledge of the software languages and all, so function keeps repeating. So suppose there is a function, it will keep doing that whenever we want in the entire.
Yes. So whenever you call this function, it will do it will perform the logic written in it based upon the parameters that you have passed. it will do the execution and return back the value.
So that was my first question. The second is we can change this value 532 in the upcoming steps if we want.
Yeah. So here I am now creating another object X, which is in capital case, and I'm saying C246. I'm changed the parameter values.
But this is a different object, right?
Yes.
Naming convention changes, everything changes.
See, okay, if you want this to be small x,
Then it is over. Then it will override.
it will override the original x. It will overwrite. Simple. What, Gopal?
So it's overriding. I'm just trying to understand how it is so easy to override something. And,
See, I think so. Don't go into how the CPU performs in the background. Don't go into how memory chipset is created, how the sand on which we walk, how that sand is used to create the chipset. It's as simple as that. It's overwriting. Let's accept it. How it is overwriting in the random access memory, it's not our botheration.
no, it's just that it's so easy to replace. So in that case, if you're assigning a number to any variable, it could be overwritten so easily.
Yes.
No, you're doing this just to make your work easier. Okay. You're calling something so that you call X.
See, there is a syntax, right? Okay.
It's designed like that.
It designed like that. It does not want to be something where things has to be very, yeah, very hard for us to change values, right? So here I'll make it back to capital X. So I've now created X, which is a vector, and associated a sequence of values. So I'll run this statement, I'll run this statement, and I'll now, because I have captured those objects in small x and capital X, to display the values, I simply call the object name and it gets displayed. Okay. So let's run the basic syntax where we are now going to create vector, run these two syntaxes. This the syntax is for small x and capital X. Please note R is case sensitive. As such, small x and capital X are two different objects. Yeah. Just run the left hand side part of the syntax.
I'm not able to access that R Studio script. I'm writing in the R editor.
It's okay. Run, it's
Inside most of the time you have to write it not in the console because console wouldn't remember it, but
always write on the editor. Always write on the editor. That's a best practice. Yeah. Okay. Likewise, write the syntax for small y and capital Y. The first one is capital Y, where I'm saying x plus x. So here what I'm doing is, now what I'm trying to show is, you can do vector addition. X is a vector. See, only one value if you assign, we'll call it a vector of 1. or we call it scalar. When I'm associating many values, I can directly say vector. So X is a vector. This capital X is also a vector. Now I'm doing vector addition. If I'm adding this set of values with this set of values, what output do you expect? I'm adding this set of values 532 with 246. What values do you expect? 778, right?
Because X will add to X, Y will add to Y.
Yeah, X will the first element of X will add, small x will add with the first element of capital X.
So I'm talking about dimensions of X, Y, Z. So vector will
Yeah,
have 3 dimensions.
yeah. So here the first element of X will get added with the first element of the capital X. Second element will get added with this. Third element will get added with this. And that's why you get 5 plus 2, 7, 4 plus 3, 7, 6 plus 2, 8. When I do x minus x, what will happen? It will be 5 minus 2, 3, 3 minus 4 minus 1, 2 minus 6 minus 4, and that's how you get the output. So run the other set of syntax also.
So the other set of syntax when you are running it in the editor, it's not coming up. However, I
Eh.
suppose when you do it in the console, it will probably.
See, in editor you have to first type the syntax.
Right.
And once you have typed the syntax in editor, you have to go to that line. For example, I am here and then I have to press Control Enter.
Control Enter.
Yeah, if I'm using RStudio, you can use Control Enter or Control R. Both of them will.
Is not working.
In RStudio, both of them works. In your base editor, which comes naturally with the interface, it has to be a Control R.
Because if I'm entering Control R, here it's in the console it's showing X plus X.
Yeah,
Ideally it should show the value, right?
Chandan is going to help you. When you again see, when you are right, it's running y is equal to x plus x. Addition of x plus x will happen.
Yeah.
Once the addition is happened, it returns the object. Is someone there to capture that object? Y is the object, so it will not display.
And again you have to run or execute Y.
Then you have to execute y and then it will display.
Because there's no one to catch.
See, Gopal.
Okay, got that.
Okay. So when we have executed these commands, so when I say this one, let us now try a simple thing. I created X and capital X vectors. Just put it on. We created vectors. Yeah, pull. We created vector X having 3 elements. We created capital X having 3 elements. What if I create small x having not 3 but say 5 elements? Okay, I've created this vector. I don't need to run the capital X again because I'm not changing it. What will be the output of these two calculations? There is some warning message. What will be the output for y? What will be the output for small y? See what I have done. Initially I had 3 elements. Now I have made it 5 elements. But this one I have kept 3 elements only. Now I am doing x plus x.
So it will assume the fourth and fifth parameter of capital X as 0 and it will add 4 plus 0 and 7 plus 0.
That is one logic. But here it is not going to assume the fourth and fifth parameter of capital X will be 0. What it will do is it will recycle these values. So 5 will get added with 2, 3 will get added with 4, 2 will get added with 6. Now 4 does not have a counterpart, so it is going to recycle these values. 4 will get added to 2, 7 will get added to 4, and now there is nothing more forward, so it will give the output. And that's the message it is saying, that longer object length is not a multiple of a shorter object length. So here now if you see the output, this is how the output have come. 5 plus 2, 7. I got 7 when I'm doing addition. 3 plus 4, 7. 2 plus 6, 8. 4 plus what? 4 plus 2, 6. 7 plus 4, 11. Now let's see the difference one. X minus x. 5 minus 2, 3. 3 minus 4, minus 1. 2 minus 6, minus 4. Now this 4 minus what? 4 minus this 2. I get 2. 7 minus 4, I get 3. In case this would have been like this, in this case, when you do this calculation, you will not get the warning. It will silently do it. Why? Because now the shorter object is a multiple of the longer object. What I have done is I have made 6 element here. 3 multiplied by 2, 6. So it will iterate 2 times. So now shorter object is a multiple of the longer object. That's why it will not giving me this warning. It silently executed it and I can get the outputs. Yeah? Okay.
What is the backend logic system? So how does it automatically
Automatically. It automatically sees that I'm doing a vector addition. For vector addition, it will first see whether both objects are of same size. If yes, there is no problem. If no, then it sees which object is of larger size. Then it will recycle the smaller object so that it becomes equal to larger object for the computation purpose. There is no change going to happen in this value. Capital X will continue to remain same, but it's just going to recycle its values for the addition purpose only, nothing else.
But in maths, that logic used to happen. 0 assume that
That's a implementation that they have done here. Yeah. Okay. Now one of the key characteristics of vector is all values in a vector should be of the same type. Is 5 numeric? Is 3 numeric? 2 also numeric? All are of the same type, numeric. One of the key characteristics of a vector is all values should be of the same type. Okay? Let's see now. Let's see that example. Z is equal to 5, 3. I will not put A. I'll put here 1. Anything which is in a double quote will be a character. Now here 1 is a character. Yeah? 1 here is a character now. It's not a number. The moment it comes in double quotes, it becomes a character. Agreed? Not agreed? No. Gopal has got a confusion. I'll solve that confusion. This again, all tools provide these kind of functionalities. This is Excel. Numbers should be right aligned. Everyone agree? Is it right aligned? It is left aligned. Why? I put a single quote there. In Excel, the moment you put a single quote and then type anything, what you are saying to Excel that what I'm typing is a text. So now even if I'm typing a number, read it as text, not as a number. Okay, so that's it will giving you a message here. Number stored as text. So all programming tools provide this facility that even numbers can be stored as text. So here also we are having the same thing. When I'm running this command, this is a number, but the moment I enclose it between double quotes, see that is Excel tool, it is R tool, so I cannot follow the same command like this single quote. It has its own rules. The rules is either you put it in single quote and close it in single quote. Okay, so the moment I enclose it in single quote, it becomes a text. What did I say? Vector. In a vector, all values should be of same type. Now 5 is numeric, 3 is numeric, 1 is numeric here. No. So if I run this, will it give me error? It will not give me error. Why is it that so? No. Even if I would have put it as double quote, it will not give me the error. It will be the same output. Irrespective of whether I put single quote or double quote, it does not make a difference.
Value. So it's integer or number or alphabet or something. Just give me an output.
No. But the rule for a vector is all values in a vector should be of same type. That is a rule. A rule is a rule. Once you have made a grammar, the tool has to follow the grammar. Okay? Why? There is a concept called casting. Yeah, there is a concept called casting. A number can be converted to character. Can a character be converted to number? Can you convert character A to number?
If you assign a value, yes.
No, what value? Character A is character A. What value can I? Character A is a value.
I don't think so, but if it is assigned there,
No, I'm saying a character A. I'm not saying a variable A. I'm saying a character A. Can I convert character A into number? Can I convert number 1 into character?
yes.
Yes. So, number can be casted to character. So here, when I say C531, it sees one of the element is character, two of the elements are number. Number can be converted to character. So the moment it sees this, you see all of these values are now enclosed in double quotes. What has happened is, though I passed numbers, it has casted those numbers into characters.
Although you have just pulling just on one number,
Yes,
it will take it.
yes, it will convert everything as character. Because that is the rule that a vector has a sequence of values and all values should be of same type. So there is a auto casting which the programming tool does internally. Yeah.
And if we assign two variables like this only, one character and two numeric, and then add them,
Hmm.
then it will show some error because it will convert it to characters first because there is a casting.
Let us do that also. Let us do that also. Just try first this syntax. And here if you see in RStudio, as we are typing, all these variables are available on the right hand side. It keeps showing me X is a vector of type number. It has got three elements. The first 1, 2, 3 is to indicate that there are three elements in it, and the values are 2, 4, 6. X is of type number with 6 elements, with the values are here. So if it would have been a vector which is too big, then it would have shown only some indicative values. Okay. I'm now creating a variable capital Z. Z is a vector of three elements, and we have seen that when we created Z, the values we passed numbers, one of them was text or character, and everything got converted to text format, right? So I'll now say Z is equal to small z plus y. Y has got three elements in it. No, I'll say capital X. Capital X is this one. It's got three elements in it. So I'll say Z is equal to small z. Small z is this one. And capital X. Capital X has got three values in it. 2, 4, 6. What will happen if I run this syntax?
It should give error.
Hmm? Let's run this.
Because it's characters and numbers.
Okay. Some programming languages, what they are going to do, they will again autocast. Can all these, it will, what some programming tools will do, here it has not done in R. Some programming tools, what they will do, they will see the values of Z. The values of Z is 5. It is a character 5. There's number 5 stored as a text. Can it be converted to number? It can be converted to number. This is number 3 stored as text. Can it be converted to number? It can be converted. This is number 1. Can it be converted to number text? Number 1 stored as text. Can it be converted to number? It can. The values of capital X are all numbers. Some programming tools, it will see if the values which are there in that variable, can it be converted back to a format by which the addition could have been done, and if it could have done, it would perform it. But in R, it is not doing it, because it is just saying there is a character, there is a number, addition of character with number cannot happen. As such, it directly gives you error. Okay? Yeah? I hope this part is clear.
So what you are saying, the comparison between other languages is it will convert this character into
Numbers.
numbers.
But if it would have been A, B, C, it will not do. Then it will also give error. Because A, B, C cannot be converted to numbers. But what I'm trying to say is some programming tool will see whether elements stored in it are actually of type number but formatted as characters. If that is the case, so here if when I did Excel, is this number 1? Is it, the first one is a number, second is also a number but stored as a text. Let us do this one. Is equal to, it did the calculation.
It knows it's a number, but like we are saying it is a text.
So that's what I'm saying. Some programming tools, they know if they are able to see that the values stored are numbers, but actually they have been formatted as text. So they will automatically try to see, can I do that conversion? Then they will do the calculation quietly. But R is not doing it. Yeah? Yeah. Hmm. Hmm. Yeah.
So instead of 5, 3 and 1, can we give A, B and C and initialize another
Sure.
for A,
So quickly create a vector and you initialize the values for that vector as A, B, C. If you initialize the values for variable A, B, C, it will do. Okay. So what you are saying is, I already have this A, I already have this B, and I have C. If I do this as A, B, C is equal to C, A, comma, B, comma, C, right? So here what I'm doing is I'm referencing the object A, I'm referencing the object B, I'm referencing the object C. So first thing what will happen is when I just type A here, what happens? Value comes here and gets displayed. So when I type here, the value will come, 10 will come and get sticked here. When I execute that, this will happen in memory. Okay. So in memory, when this command goes, just imagine that this command from my console, something which is seen here, displayed here, this same statement now goes into memory. In memory, then it says, okay, where is A? Is there A available? It says A is available. A will get replaced by 10. B, is B available? Yes, B is available. The value is 15. Is C available? Yes, C is available. The value is 25. So this syntax in memory will get converted as C 10, 15, 25. I'm just telling you what will happen in memory, how the processing will happen. Now, this is same syntax like what we give for vector formation. So when I run this syntax, ABC object is created. If you see here, ABC object num of type numeric having three values, 1 colon 3, 1, 2, 3. There are three values. It's just trying to show how many values are there. From 1 to 3, there are three values and the values are 10, 15, 25. If I type it here, 10, 15, 25. Yeah. Now what I want you to do is create a vector XYZ, name it XYZ, and the values for that vector should be character X, character Y, character Z. Run the syntax. Run it.
It returns character X, character Y, character Z.
Yes. Vaibhav, done?
What I'm saying is we can close this and increase the temperature of the AC.
Okay. So everyone able to do it? So the syntax would have been something like this. I'm labeling it, naming it as capital. Otherwise the syntax would have been something like this. C. You could have named it as small case. It's okay. Just this would have been the something like this, right? When I write X, Y, Z, I got that right. Yeah. So simple rule, if the values are enclosed between double quote, it means character values. Yeah. If the values are not enclosed in double quote, it means numeric values. Yeah. Sorry? It's numeric. What he is trying to say is, how do we assign decimals? Okay. Yeah. The higher one will take precedence. If there is a number, if there is a number which is in decimal and there is a number which is not in decimal, that is integer, if you add them, the higher one will take precedence. Which is higher one? The one which has got decimal. So it will take precedence. Yeah. Okay. Let's move forward from vector. Matrices. What we started off with, single value. So a single value could be represented in, like, for example, we started off with something, say x, and then I assign the value 1 to it. Okay. Then we started and we said, okay, I want to assign some 3-4 values to it. This becomes the, if we represent things in Excel, this becomes the column head, and these are the values which are in this column head. This is like one column, but quite often data does not come in one column format. Data comes in this format. What do you call this format?
There is a matrix X, Y, Z.
It is a matrix, right? It is a 4x4 matrix. So the next concept, matrix. Yeah. When data is structured in row and column format, when data is structured in a row by column format, we call it as a matrix. So here to a matrix, first what I have to pass is a set of values. See, please understand, we are working with a programming tool. We are not working on Excel. Like here, I simply typed some values. So I have to give instructions through some syntax. So the syntax here is to store information in a row by column format. I have to use a syntax which is named as matrix. I call the matrix function. Now whenever there is a function accepts certain parameters as input. A function accepts certain parameters as an input, and then you get an output. Now here matrix requires certain information. The first is basically the values which you would like to arrange in a matrix kind of a structure. So I am passing it a sequence of values 1, 3, 5, 2, 6, 7. I want to put them together. That's why I am making it as a using the function C. So this becomes my first parameter to a matrix, that I want the values 1, 3, 5, 2, 6 and 7 should be arranged in a matrix format. Now if there are 6 values, I can create a matrix which is 1 by 6. I can create a matrix which is 2 by 3. I can create a matrix which is 3 by 2. Agreed? Or I can create a matrix which is 6 by 1. So I need to tell the matrix how many rows and how many columns do I desire. So I am saying that these 6 values should be arranged in 2 rows, 3 columns. Yeah. So when I run this command, this is the command. What I've selected, just type it. M is equal to matrix, bracket open. Please ensure the number of brackets that you open should be equal to numbers of brackets that you close.
So to start with those matrix, m equal to matrix and the assigned thing,
Yeah.
you also have to enter that.
See, programming is like a set of instructions. And those instructions you pass like a parameter values. So here, this is the first parameter. So n row is equal to 2. Now, let me also show you. So here, when I pass this parameter, this syntax, when I'm saying n row equal to 2, you understand that I am passing the value 2 to the parameter which is named as n row. When I'm passing 3, you clearly understand that I am passing the parameter to n call. What has happened is I have not named the parameter name here. I should have actually typed it like this. Data equal to. It's the same because this is the function. This is the defined function. What it says is the first parameter you have to pass, which is named as data. The second parameter you have to pass it as one column, n row. The third parameter you have to pass it as column. So here I could have run the same syntax like this also. I could have executed this like this. If I execute it like this, what will happen? 2 rows, 3 columns. Why 2 rows, 3 columns?
Because the syntax is n row first and then n column.
Yes. So basically the point is if I do not give the parameter name here, the values will, this value, the first value will go to the first parameter which is defined in the function. The next value will go to the next parameter. The third value will go to the third parameter. There is a fourth parameter also by row. Have I passed any value for the fourth parameter? I have not passed a value for fourth parameter. If I have not passed value for the fourth parameter, what will be the value of the fourth parameter? By default, it is false. Because if you see the way it has been defined, data is equal to NA, NA is no object. Okay, so which means without this parameter you cannot do anything. So this parameter value has to be definitely provided. Other parameters, it has default assume nrow is 1, ncall is 1. By row is default false. If you don't pass, it will take those parameters. Okay.
Rajesh, tell me one thing. Initially, in the first m equal to matrix bracket, you just entered C and then the rest of the data. But why did we put data later? Why did we enter that?
No need. I was just saying that this syntax, that is what I was explaining. That when I don't pass the parameter name here, this value will go to which parameter? That is small m is the object that will be created. But before, see, this is a function. Okay. When you're calling a function, this is the first value to the function. This value will go to which parameter? Why data? Because if you see the syntax of it, this is where the function documentation is. In the function documentation, it says data is the first parameter. It's like this. If you are working on Excel, you call some function equal to VLOOKUP. I can write this syntax like this also. Lookup underscore value is equal to comma table underscore array is equal to comma column index 2. Rather than saying just 2, I could have written it like this also. Call underscore index underscore num equal to 2. Huh? Why we don't do this? Because in Excel, when you do this, the sequence in which you give the values, E2 automatically gets associated with lookup value. This range automatically gets associated with table array. This 2 automatically gets associated with call index number. Okay. So here also, in R also, if I don't give these things, where will they get associated? They will get associated with the parameter data nrow ncall, which is in that sequence. Gopal, you need to see on the screen that I'm showing you. Here is the documentation of matrix function. In the documentation of matrix function, it is saying the first parameter is data. That's why if I don't give the name data, the first parameter will automatically get mapped to this. The second parameter will automatically get mapped to this parameter. The third parameter will automatically get mapped to this. If you, or probably this is the what it is, matrix, the bracket. Okay. I could have done the same thing in case I don't pass these parameters in this sequence. I don't wish to pass these parameters in this sequence. I want to pass it like this. Will it run? No. Why? Uh, it will not. But if I do this thing like this now, nrow equal to ncall equal to data equal to, and then run it, it will run. So if you are passing the values in the sequence in which the parameter it is expecting, you did not give the parameter names. Are you getting? But if you are not passing the parameter values in the sequence, then you have to write the parameter names. Okay? Make sense? So everyone tried this matrix function? Okay. I'll explain that. So here when we created it, Let us see the output of this small m. The values are 1, 3, 5, 2, 6, 7. I could have written this value 1, 3, 5, 2, 6, 7 like this. 1, 3, 5, 2, 6, 7. I could have written it like this. Is this a matrix structure? But this is the format in which R has given it. So what R in background, what it is said, by row is equal to false, which means by call is equal to true, right? So what it is saying is by row equal to false. What it is saying is the value should be written like this: 1, 3, 5, 2, 6, 7, column wise, not row wise. First fill the values in a column, first column, then fill the values in the second column, then fill the values in the third column.
Okay, so if we change by row is equal to true.
How do we change it now? By adding this one more parameter. So when I write this parameter and now I see the value, you will see 1, 3, 5, 2, 6, 7. Yeah? Okay? So let us move forward from matrix.
One more
Yeah.
this thing in previous
Dim names.
what is that?
Dim name is assigning. What is the name for this column?
Acha.
There is no name. What is the name for this column? There is no name. So what has happened is the column index number has become the column names. If you wish to assign the names to these columns and rows, you can assign it using dim names functionality.
So for example, if you want to create a table for three people, A, B, C, so we can give dim names as A, B, and C, and that matrix will.
We'll display that dim names as A, B, C rather than showing it as 1, 2, and 3.
So dim names equal to A, B, C is the syntax, or A, comma, B, comma, C.
No, the syntax you will have to find like this. So any of these things when you send, okay. So it will be like this. Dim names,
Again a function.
list and call names. You have to.
List is the function, and then again two character.
So you have to see the syntax. You have to go through the help document, find it, and then execute it. Yeah. So let's matrix. A matrix is a table kind of a structure where values are arranged in row and column format, and again the restriction is all values in the matrix should be of the same type. What would have happened if one of the value I would have made, what would have happened?
Convert everything to character.
Okay, it will convert everything to character. Yeah. Let's move forward. How to get help you already seen.
Okay, I'll just write it.
What one?
I just want to write that help syntax.
Either question mark and the function name, or help bracket the function name bracket close. Yeah. Now let's move forward to the next data type, which is called list. When we are working on R, is it necessary that all values that we have should be always be of same type? Sometimes it may so happen we require a programming object where certain values will be numeric, certain values will be characters. It's simple like when we go out shopping, we create a shopping list. And when we create a shopping list, is it that all items that are in the shopping list is everything of apparel only? No. When you create a shopping list, there are some items which are apparel, some items will be maybe of electronics, some items may be from food items. So there are different types of items. So a list is something of same type, wherein if you want to have values which are of different types, in that case you have to use a programming structure, data structure, which can store values of different type. In that case, you will have to use a list instead of a vector. Okay? A list is like a vector, but it can store values of different types.
It's a list.
It's a list. It's a simple list. What we create: sequence number 1, item number; sequence number 2, item name; sequence number 3, item name; sequence number 4, item name. So similarly, in list, everything will be in a sequence. Okay? That is the first element. Now when you create a list, you can store values as key value pair. You can store values as a key value pair. So here in the first syntax, what am I doing? I am creating a list which is an empty list. L1 is equal to list bracket open close. It is an empty list. Is there any values in it? No. So this is an empty list. Let's create an empty list first. L1 equal to run these two syntax. And now here, if you would have noted in my code, there's many places you see this hash and something. Hash comment. So comment is in programming language, when you write something, when you're writing a code, if you are revisiting that code after say 3 months, okay, will you remember what logic did you write? You will not. So to enable you to remember what logic you have written in it, you typically put comments there. So here, the moment I say hash, I am creating an empty list. After 6 months, if I revisit this code and then I see L1 is equal to list L1, immediately I will understand, oh, okay, in this step I am creating an empty list. Why? There is a comment here. Comment does not get, it's not a code which will be interpreted and something syntax will get executed and something will happen. It's just a comment. So even if I run this, nothing will happen. See, my cursor is here. My cursor is here. I'm pressing Control R. If I type something here, empty list, nothing will happen and it will just come back. No object is formed in the background. Okay, so that is a comment.
So suppose we have mentioned a comment and we came back to the working area of where we were working. And so how do we reach to this?
Basically, say it's like this. This is my code. Okay, I'll just open another file of mine. This is a classification tree. There's some logic here. I know in this code somewhere I have written logic to build a random forest model. Where it is, I don't know, but I know somewhere I have written it. Here, building the model using random forest. So the moment I see this comment, I can come to know, okay, from here, I've written a code for building a random forest model.
Okay, so I got it wrong first time. So it's just to remember from where this code is.
It is for us.
For us, for our convenience actually.
It's for our convenience. It's like when you're doing legal documentation. Assume you're doing an agreement, and which probably in marketing you will be keep doing. You sign agreements with people, right? And so long as agreement is not finalized, you make a draft. Then you send the draft to the counterparty. The counterparty reviews the draft, and then they make alteration. Now, for you to quickly understand where they have made alteration, there's some color coding that comes up automatically because you're making changes in track change mode. Now, when they are making change, they sometimes want you to understand their perspective of why they are making a change. So there they may select that track change and insert a comment. In Word document, that track change comes in the side corner, right?
Yeah.
The objective of that comment is to communicate with the other person. For example, if I am writing a code and tomorrow I share that code with my team member, and assume for some reason I'm going on a vacation and I don't want anyone to disturb, that's why I'm not taking my office mobile and I'm just taking my personal mobile and I'm not giving that number to anyone. Someone else in the organization has to work on my behalf. Now if he or she is working on the same code but they are not able to understand the logic, what are they going to do? They are going to call me, but I'm not reachable. So either they will be stuck or they will have to break their head to understand the logic. Or if there is these kind of small lines written, why I am writing this piece of code, why I am writing this piece of code, why I am doing this, they can read that lines, understand what my objective was in writing that statement. So a comment helps communicate with the other person what you are trying to do in the code. A comment helps you revisit your code and easily recollect what you did in past.
So it's just a reference.
Yeah.
Yeah.
So commenting is always a best practice. So here I am creating a empty list. L1 is equal to list. Now here this syntax L2 is equal to list name is equal to RJ. As I said, in a list you can keep values in a key value pair. Here name is the key, RJ is the value. Age equal to 20. Age is the key, 20 is the value. So I'm now creating here a list having two elements. The first element is named as name. Second element is named age. So when I run this syntax, so okay, we executed this syntax, it just returns empty list. When I run this syntax, the object is created. It says the first element is $name, which has got value RJ. Second element is got $age. Thank you. So the second element is $age and the value is 20. Dollar is to indicate that it is a element in the list. So here, if this is list L2 dollar name, I can access an element like this also. Okay. Everyone done? Okay. Let us come to the third element. Let us come to the third element. I'm now creating a list L3. Value is RJ and second value is 20. I said the values are stored as key value pair. In this case, I'm not giving any key. So what will happen is a sequence number. Automatically it will get a sequence number. So here, when I run this L3, I run this L3. Can you see bracket 1 coming here? In the previous syntax, when I executed it, it said dollar name because I gave a key. But now what has happened is the sequence number is taking over. Yeah? But I cannot access this thing like this now. L3 $1. I cannot access this like this.
So will you be able to access it by using the square brackets open close?
Yeah. So I'll be able to access it by the element row number. Is the first element, I'll use the 1. Is the second element, I'll use 2.
I just want to get the terminologies right. So name is the key.
Name is the key.
Okay, and age is also key. Then
Huh.
RJ is the value assigned to name and 20 is the value.
Yes.
List is a function.
List is a data structure, not a function. But okay, this list.
Yeah, this list.
Okay. This list is a function which returns the object of type list.
Right.
It's a function. This list is small list is a function. Yeah.
But list as a topic is a
Data structure. To create that data structure, for example, to create a scalar and a vector, to create a vector we use the function C. To create a list object, we are using the function list.
So multiple list names in one list.
Multiple lists can reside in one list. Possible. How? Okay. L2 is a list. L3 is a list. Let us create L23 is equal to. I can use equal to or I can use this. List is a function. L2 is the object of type list. L3 is the object of type list. L23 is created, where L2 is its first element, L3 is its second element. Now let us see L23. This is the first element of L23. The first element of L23 is what? A list. In that list, there were two elements. So this is the first element of the list L2 and the value is RJ. This is the second element of list L2 and the name was age and the value is 20. This bracket 2 is the second element of list L23. This the there are this is the first element of second list, second object. This is the second element of second object. Here, because name and age were the tags that came here, here that name tags were not there. So it has said 1 and 2. A list can contain a list.
And we can call a list from an Excel, other file sources like that.
You can call a list from a?
Other sources, Excel?
No. No. You can import data from other sources. You can import data from other sources. When you're importing it, typically when you import it, there will be import functionalities. And that will be called as typically when you import data from Excel or a CSV, data get imported as data frame. Data gets imported as a data frame. Okay. Okay. Everyone tried these syntaxes? Okay. When we created list L1, it was an empty list. When you create a shopping list, all of a sudden you recollect some more item to be purchased. What do you do? Edit the list. And typically you will directly edit the list by adding that item at the end of the list. Right? So I can add elements to a list. So here L1, let us just quickly see L1 once. Let us quickly run this L1 only. It is an empty list. Now let us add the first element. To add the first element now, because it is an empty list, the element that I am going to add can go in the first position. If instead of running this syntax, I try to run this syntax, let us try this. What will happen? L1 2.
Second element of L1 list is 20.
That should not happen. The first element, it is assigned as null. And second element, it has assigned 20. Okay. Now let us do this. We'll do that one. Let us do this. Is there any third element there? No. Third element is null. When you create a list, shopping list, sometimes you keep spaces in between to allow some new items to be added in between, right? तो ये null छोड़ दिया अपन ने. We have kept this as null. I did not execute it. I did not execute. That's what I said. Let us not execute it. So now let's execute it. So now I have executed it. So sorry. Now when I execute it, first element value has come, second element value is there, third I did not assign, fourth is there. I can now add the third element also, equals to, now if I see L1, all values are there, first, second, third, fourth. So this list is like your list. See, it's again, when these elements are created, these objects are created, they are trying to create something which is naturally understandable. Yeah. So if you can just think what we normally, the way we would do, it does it. So other simple way of doing is, Gopal, you don't have to use programming tool now. You have to hear what I'm saying and then do something. A is equal to 500. B is equal to 300. C is equal to 200. D is equal to A plus B plus C. What is the value of D? 1000. What did you do? Where did you do that mathematics? In your brain. In your RAM. So what is happening when I said A equal to 500? In our brain we registered it. B is equal to 300. In our brain we registered it. C equal to 200. In our brain we registered it. And when I said D is equal to A plus B plus C, brain is our CPU, which has also got the RAM place. In that everything was getting stored and things were executing and we got the output. So similarly, when we are running all these syntaxes, when I say something, this is equal to this, there is a CPU and there is a RAM. In computer, the CPU processes, the process information goes in the RAM, which is our memory in this case. That's what programming is. Right? Only thing is, we are trying to interact with it in a programming syntax using the programming grammar. If we violate it, computer will not understand what we are trying to do. Yeah. So this is the concept of list. So now please add values on L1. So this was L1, which is empty list. Create this L1.
see whether these things have got added? Is there a syntax?
We have been able to see, no? The moment I said this L1, it's showing me all, no? First element is RJ, second element is 20, third element is K2, fourth element is 50, right? Okay, so we executed these syntax and we have seen how to go about adding it. Now if I want to delete it, the moment I delete a element from a list, what will happen? If I delete the first element of the list, what? The rest of the elements will be still be there, but their sequence number will change. They will move up. They'll move up. So here, the moment I say L1, L1 first element has to be deleted. Delete, you have to make it null. In programming languages, null means nothing. Null means void, nothing. So the moment I say null, L1 first element, L1 bracket 1 is equal to null, I am deleting the first element. So the moment I say this, the first element is dropped. And now if I see L1 20, which was the second element, it has moved to position 1. K2, which was the third, has moved to position 2. 50, which was at position 4, has moved to position 3. Okay. Just try that.
Have you shared that codings to us?
Sorry?
Have you shared that coding with us?
If I would have shared the codes, you would not have typed the code. Yeah. Okay. Let us move forward. Now here what we are going to create is a list having list and vector as its element. We have already seen a list having two lists as its element. Now we are going to see a list having one element as list and another element as vector. So here I am creating a vector. The name of that vector I am giving capital V and the values is basically 1, 2, 3, 4. Second, I am creating L4 as a list where first element I am saying list element is equal to L1, vector element is equal to V. Okay, so let us see that. So the code syntax is here. V is my vector, L4 is my syntax, and L4. So here you can see that L4, when I say, it shows list element, and then first element of this list element, it is showing the value, then it's showing the second element of the list element, and then it is showing the third element of the list element, and then it's showing the vector element, the values of this vector element 1, 2, 3, 4. Yeah. So just try this syntax. These 3 lines of code which are highlighted is what you have to type. So what we said, a list can have objects of different types. Here I'm just showing an example. See, so far what we are doing is RJ, 20, K2, 50. They are objects of type character and number. Now we are creating complicated objects. Vector is an object in itself, which is a sequence of values. A list is an object where it has got sequence of values which are of different type, right? So the type of this object is list. The type of this object is a vector. Now I am creating a list in which first element I am saying is a list. The second element I am giving the name as vector element, and the value I am assigning as a vector object, and then I am displaying it.
List element is a function.
List element is a name. It's a key value syntax that I have used now.
So it's not predefined.
No, list element is in a list function.
Very similar to name tag.
A sequence. No, no, no. I could have given it anything. I could have said
Understand.
A, B, C also.
No, I was looking through the tab thing.
I mean, yeah. Space cannot come here because this is a name. No, not here. Vector space element, not possible. It's a variable name.
Right. And this space will be fine.
This is okay.
This is okay. Now again, if I run this,
Yeah, done. Okay.
What is the output you got?
Basically, output will show as a list element and then values in that, then a vector element and the values in it. So here you will get a slightly complicated output like this because we created a list which has got, yeah, because you did not drop RJ. I dropped. No.
I did. I can show it to you.
The,
I did L11 equal to null,
huh.
and after that I executed L1 as well, and it was
Null in caps, huh? What's more?
so null all the characters in caps on.
Yes. Now it is good.
So it was.
Okay. So we have done adding elements, deleting elements, and we have seen list having objects of different types, just not characters and numbers also, but also objects of type object, like a list, like a vector in it. Now, how we can access the elements? We have already used these single brackets and double brackets. Let us quickly see the usage of single brackets and double brackets. We had this list L4 which we had created earlier. Okay, we have made many elements in it. Now if I want the first element of it to be accessed, I can say like this. The first element is named as list element, so it is showing it, and within that the first value is 20, in that the second element is Q2, in that the third element is 50, so I am able to access it. Yeah.
So that means list 4 is a list whose first element is a list, so it is showing all the elements of the
Yes.
that list.
Or you can now say that it is a sublist.
Yes.
The first element is a sublist.
So 1 and 2 equal?
L4 bracket 2.
No. Can you call both together? No, just calling L4 will do. Okay, okay.
Okay. So when I call the second element, it shows that the name of that second element is dollar vector element, and then 1, 2, 3, 4 are the values in it.
So when
Okay.
we call L4,
Yeah.
so it condensed output.
Yes, it shows all the elements.
All the elements, but we don't get the bifurcation of the sublist.
Yes. Now I am calling these elements by using single brackets. Now let us see what happens if I call it with two brackets. Okay. L4 bracket 1. I get this output. Let us compare this. When I call it with a single bracket, no, it's not same. When I called with a single bracket, it first gave me this list element, and then it said $list element and the first value. Then it returned $list element and the second value. Then it said $list element and third value.
It already assumes the.
Now when I call this syntax with two brackets, is it showing me $list element? No. What is happening is,
Does it skip that?
yes. So when you call with a single bracket, all objects in a list are stored as a sublist. All objects in a list are stored as a sublist. Even if I pass a vector, object, it is stored in it as a sublist. If you recollect, the second element, this V, is a vector. We created in a vector kind of a syntax. When I call this second element of this, it returns me this kind of a output. Let us capture this output in some object. L4 object 2, or element, I'll use the word element 2, okay, is equal to L4 bracket 2. If there is any object that is created, I can find that object is of what class, of what type. How do I find it? I can find that using a function called class. Now when I pass it, it will give me the class of this object. What does it say?
It's a list.
List. But second element, what object did I pass to it?
So the
Vector. This was it that we passed. V. This was the, right? Let us see the class of this V. Class of V, it will say numeric. The reason it will say numeric, because a vector has values of same type. If all values are of numeric type, it is not going to say vector, because if it just says vector, you will not know whether the values inside are numeric or whether the values inside are character. So rather than saying vector, it uses the final data type of the values which are stored in the vector. So it is numeric, so it has said numeric. If it would have been vector of character, it would have said character. But here, when I took the second element and I saw the class, it's a list. Reason is, all objects which are passed as a parameter values to a list, they get stored inside a list as a sublist. And that's why when you access it, it shows the class as list. Now, in case we would have accessed it instead of like this with a one rectangular bracket, if we would have accessed it as two rectangular brackets, what it would do a two steps. The first step would be go to the second element of the list L4. It got that object. The second rectangular bracket then says go inside that object, get the values of it and return the values back. So when I do this syntax and now I see it, it says numeric. So hope you saw the difference between usage of a single rectangular bracket and double rectangular bracket. A single rectangular bracket way of accessing a element in a list. It will go to that object, take that object, return it back. But all objects in a list are stored as a sublist. As such, you will get a list. But when you type two rectangular brackets, first bracket will say go into it, get it, it is a list. The second rectangular bracket says now go inside it, get the values which are there, and those values are returned. That's the difference between a single rectangular bracket usage and a double rectangular bracket usage.